Hey guys, I'm Jay. Today is my LeetCode review one take vlog on 102nd problem, binary tree level order traversal. We are given the root of a binary tree. We'll return the level order traversal of its nodes value from left to right and level by level. Let's see example 1 here to understand this problem easily. We got empty binary tree here, and our output should be 3 in level 0. And 9 and 20 in level 1, and 15 and 7 in the level 2. And if the tree is an empty tree, we just return an empty list. Then let's get started with our intuition to solve the problem. Intuition to solve the problem. So the level order traversal of a binary tree is basically a breadth first search traversal. We can use a queue to help us visit each node level by level. First, we start by enqueuing the root node. Then we repeatedly dequeue a node, process it, and enqueue its left and right subtree. This ensures that nodes are processed in order of their levels. Then let's get started with the first approach, using a queue for the breadth first search. First, we'll create a list to store the level order traversal, and the type is list of integer. Let's call it list, and we create a new array list for the variable. Then we'll check the back case. If the root is null, we just return an empty list because there are no nodes to traverse. If root node equals null, we just return the empty list. Or we'll create a queue to help us keep track of nodes to be processed at each level. The type is queue of tree node. Let's call it queue. We create a new linked list for the variable. Then we'll add a root node into the queue with queue.offer or queue.add with the root node. Then we'll implement a while loop to do the traversal, and the condition is while there are nodes to be processed. So the code is not logical symbol with queue that is empty. And for each iteration, first we'll create a list to store nodes at the current level. So the code is list of integer. Let's call it, let's say, value list with a new array list. Then we have to get the number of nodes at current level by checking the queue size. Integer level size equals queue.size. And then we'll create another for loop to process all the nodes at the current level. Let's say for integer I started at 0, I should be less than level size. We increment I after each iteration. And inside the for loop, first we'll dequeue the front node from the queue. The code is tree node with node equals queue.haul. Then we'll add its value into the current level list, which is value list.add with node.value. Then we'll enqueue the left subtree and right subtree of the current node. into the queue for the next iteration if they exist. If no.left is not equal to now, then we'll add the left subtree into the queue for the next iteration, queue.add or queue.offer with no.left. And we'll do the similar action for the right subtree, queue.offer with no.right. And after processing all the nodes at current level, then we'll add the value list into the final result list out of the for loop. So the code is list at value list. Oops. And out of the value, which means we have processed all the levels and their corresponding nodes. So we just return the list. Let's submit code, check for the correctness. Oops. I have to revise the type. Let's submit code and check for the correctness, and then let's analyze the time and space complexity. Yes, our code got accepted. So the time complexity, it is big O of n, and n stands for the number of nodes in the binary tree. Each node is enqueued and dequeued exactly one time. And the space complexity, it is big O of n, and n could be the maximum number of nodes that can be stored in a queue at any given time. And it differs in different kind of binary tree. And this is the first approach. And there is another alternative approach. We can use the recursion to simulate the level order traversal. And then let's get started with the second approach. So for the second approach, we can do a recursion to simulate the level order traversal. And then let's get started with the code to achieve the problem. First, we still have to create a list or a result list, and the type is list of integer. Let's call it list. We assign a new array list instance into the variable, and then we'll define a recursive helper method that takes the current node, the current level, and the result list as arguments. Let's say level order helper method with 3 arguments, 3 parameters: the current node, which is root node here, and the current level, which is 0 here, and the final one, which is the result list. And after recursion, we just return the result list. Then we have to declare and implement the recursive helper method. So the code is private void level order helper with 3 parameters. First is the tree node. Let's call it node, and then the level. And the final one is the result list. List of list. Oops, we have to declare the specific type, list of integer. And inside the method body, first we still have to handle the bad case. If node equals null, which means the tree or the subtree is empty, so we'll do nothing. Or if the node is not null, then we have to check if the current level has a list or not. If no, we just add a new list into the result list. The code is level is bigger than or equal to list size. If so, which means this is our first time that comes to a new level. So we'll add a new array list into it. And then we'll add the current node's value into its corresponding level list. The code is list dot get the current level. And then we'll add the current node's value, node.value, into the corresponding level list. And then we'll recursively call the helper method for the left subtree and the right subtree if they exist. And we have to increment the level by 1. The code is we'll do a recursion level order helper with node.left and level plus 1 and the result list. And we'll do the same action for the right subtree. And that's all the code for the second approach. Let's submit the code and check for the correctness. And then let's analyze the time and space complexity. So the time complexity, it is big O of n, and n is the number of nodes. Oops. The name of the result list is list, not result. Let's resubmit again. Yes, our code got accepted. So the time complexity, it is big O of n, and n is the number of nodes in binary tree, as each node is visited only one time. And the space complexity, it is big O of h. H stands for the height of the binary tree. And it could be very different for every binary trees. For example, if the binary tree is a balanced binary tree, so the h could be log of n. But if the tree is a skewed tree, so h could be just n. And that's all of n. And that's the end of my LeetCode review vlog on this problem. And I highly recommend you guys to visit my online GitHub page here, which contains all the problem description, intuition, and the Java code with very detailed annotations, and the final time and space complex analysis. You can also visit my GitHub repository here, which contains all the code and nodes to build this online GitHub page. And I'll put those two links on my YouTube description below. And thank you guys for watching. I'll see you next time. Bye bye.